once was a story of a traveler who traveled from a vast land. Now, see, this land only had one problem. They didn't know how to solve triple rows of systems of equations. You see, they could do the normal ones. But this traveler, he knew that there was more. He knew that there was a way to solve these systems of equations. So one day he came across a fellow who seemed like he was very smart, and he seemed like this guy might know how to solve these complex systems of equations. So he asked this man, and he shot him a little video for his, school project, and ended up getting extra credit. Hopefully this is how the story ends. Well, anyway, here's that clip of that video. I hope you enjoy it. Peace out. So, we have this stupidly complex system of equations that we will be solving today. And basically what you want to do is solve for one variable so that you can fill out the rest of the equation, and it makes it a lot less complex. So I'm going to number each of my equations to make it just a little bit less confusing for y'all. And I'm going to want to see which two of these three equations will be easiest to solve for. So 1 and 3 are super easy because if I just add them together just how it is, it'll actually cancel out x and y because they're both each other times -1 for the x and y values. So both the x and the y values will cancel out, and we'll be left with z is equal to a certain number. And you'll see why I chose this in a second. So we're just writing out our equations here, and we're going to want to, once we write out our equations, we're going to want to add the two together just how they are and rewrite the equation. Okay, so we have the equations written out, and we're going to add them just how you would normally add things. So we're going to add -x to x because they're on top of each other, and those will cancel out. And we're going to add -5y to 5y, and those will also cancel out. So this is a very unique problem, and Miss Long made it very easy for us in this certain situation. So now we add -5z to -z, so we have -6z is equal to -18 because we added 2 to -20. So now we just need to solve for z in the normal fashion by dividing both sides by -6, and the final answer will be z is equal to 3. So now that we have this one answer, all we need to do is get one equation that has two variables in it, only two variables, one of them being z, so that we can substitute that into the equation so that we can solve for one of the other variables. So I chose to add equations 2 and 3 because that gets rid of the y variable. And then we will be able to supplement in z for the equation, and we'll be able to figure out what x is equal to. So here we are going to add the two equations just as we did the last time, and this will be able to cancel out y for us. Okay, so we've added our two equations now, and we have 5x plus 3z is equal to -1. And so we will be, we'll supplement 3z is obviously equal to 9 because z is equal to 3. So we have 5x plus 9 is equal to -1, and 5x is equal to -10, and finally x will be equal to -2. So now that we know what x and y are, all we have to do is go plug it back into one of the equations. And I'm just putting the answers over in the right hand corner just for simplicity. So we have z is equal to 3 and x is equal to -2. So now I just chose the first equation. You could choose any equation you want. We're going to supplement x for the x value, obviously, and z for the z value, obviously. So we're gonna be solving for y. So here I make this a negative instead of a positive, which it should be positive 2 instead of negative 2. I find this out in a second. And this is because we have negative 2, or x is negative, and we have our x value is negative as well. So this should be a positive 2. Minus 5y minus 5 times 3, and this is because we have 5 times our z value, which is 3. So we have 2 minus 5y minus 15 is equal to 2. So we solve this just as we would any other system of equations. And we have negative 13 minus 5y is equal to 2. Now we have negative 5y is equal to 15. So we have now solved our equation. We have x is equal to negative 2, y is equal to negative 3, and z is equal to 3. So how do you write this equation? Well, we write it as an ordered triple, which looks just like how you would write x and y coordinates, except for you have 3 coordinates which you have, which are, in this case, x, y, and z. So you write them in the alphabetical order. So first we have x, which is negative 2, y, which is negative 3, and z, which is 3. So this is our ordered triple, and that's how you write the equation. So we've now solved our problem, and if you went back and checked these points into this problem, that would be a way to check your answer. I did not do that in this particular instance. Hello, and welcome back. I hope you enjoyed our show. The traveler in the end did find out how to solve his systems of equations, and he was able to return to his land and show the people of his valley how to solve the systems of equations. As for the student, well, nobody knows how he did, but let's hope he gets that extra credit. Thank you, and have a nice day.